Hello, virtual people or people who are watching us for a little bit of extra help. So this is a problem that we did go through in class in the afternoon for those of you who were there. If you're virtual, then this is your first time seeing it. What we are going to talk about is this idea of a limit. So all of chapter 2 in your textbook is based off of finding limits and working with limits. So what we have here, we have a couple of things. We have an equation. We have the equation of a function here, and we have the graph of that function on the right-hand side. A few things to notice about the graph. We do see a pair of asymptotes. We have a vertical asymptote cutting down through x equals 3. We also have a horizontal asymptote cutting through at y equals 2. Now, if we look specifically at the equation that we're dealing with, so 2x squared plus 5x minus 3 divided by x squared minus 9, you may remember from pre-calc how to find those asymptotes just by looking at the equation. So if I work a little bit with this equation, another thing to notice on the graph, and the description says there's a hole at -3, 7 over 6, and that is this point right here. So it is meant to be an open circle there. That is not an error in the graph. That is meant to be there. So we have this hole, we have this equation, we have a vertical asymptote, horizontal asymptote, a lot going on here. Now, if we were to take this function and factor it, what would we get? So on the top, we have 2x, and I'm thinking it's 2x minus 1, x plus 3. On the bottom, this is just a difference of squares, pretty straightforward. This fraction does reduce, giving us this fraction. So the reduction of the fraction, being able to pull out those x plus 3's, that is what is giving us this hole right in the graph right there. We can eliminate it from the problem, we can remove it from the problem, we can reduce the fraction. What that means is we are going to have a point that is not defined. I cannot plug -3 into the original equation. If I were to plug -3 into the original equation, I would get 0 over 0, which does not exist. So the graph doesn't actually exist at that point, but it does look a lot differently than what we see over at x equals 3 with the asymptote. Now, we need to get into these limit questions. As x approaches -infinity, what does y approach is the question that we're asking ourselves here at this beginning part. So let's take a look at the graph. So looking at the graph, what we do with this type of problem, what we're looking for when we answer these types of questions, our answer is typically going to be a y value. So as x approaches -infinity, if I trace the curve, and I know you cannot see me, but if I trace the curve, and I'll do it with my pencil. So if I trace the curve and I'm starting from a point on the graph and I move towards the left, so I'm tracing the curve and I'm going towards the left because I want x is going towards -infinity, so I'm getting smaller and smaller values of x. The question is, what happens to the y value as x is getting further and further out? So we know that we have a horizontal asymptote, so our y value is really approaching +2. And that's what we're going to answer here. So as x goes to -infinity, as x goes further out to the left, what happens to the y value? The y value approaches 2. And this part might be new depending on what you had for limit notation in the past, but I would write this: the limit as x goes to -infinity of the function is 2. And we are going to move to the next question. So now we have, as x goes to +infinity, what happens to the y value? So if I trace the curve, so as I start somewhere and I'm going towards +infinity, my x values are getting bigger and bigger and bigger and bigger, and I'm following along with where the curve is going to go. What is happening to the y values? Well, the y values are approaching 2 still. So that is going to be the answer to my limit, and I would say the limit as x goes to infinity is 2. Okay, now for the next two questions, we're going to look a little bit more closely at the hole at -3. So as x goes to -3 from the left, I'm going to start on the left side. So I'm still going to trace the curve. I'm going to start on the left side of the graph, and I'm going to follow the curve, and as x approaches -3, the question is, what does the y value approach? As x is getting closer and closer to -3, what is y getting closer to? Thankfully, they gave us, back in the beginning, back in the directions, they gave us the coordinate of that hole. The y value is approaching 7/6. And that is going to be our limit. So what am I doing? X is going to -3. The way that I express from the left is I put a little negative here. It looks like a superscript. It's like a little exponent for the -3. So this is saying the limit is x goes to -3 from the left. We're going to have something similar on the next problem from the right, but it's going to be a plus sign instead of a minus sign. And we're saying it's 7/6. So for the next one, if we use the same logic, the limit is x goes to -3 from the right. So I'm tracing the curve. I'm getting closer and closer to -3 on the x-axis. What is y getting closer to? Y is getting closer to 7/6. And this is how we would write that. So the limit as x goes to -3 from the right is 7/6. Okay, now we just have 2 more problems here to talk about. Both of them are going to involve that vertical asymptote over at x equals 3. As x goes to 3 from the left, so if I start on the left side and I follow the curve and I get closer and closer to 3 on the x-axis, what is happening to the y? Well, the y is getting smaller and smaller and smaller and smaller. The y is going to -infinity, is what we can say. So when the graph goes down like that at a vertical asymptote, this is how we're going to express that answer. So the limit as x goes to 3 from the left of the function is -infinity because it's going down. As x goes to 3 from the right, so now we're looking at the other side of the graph. So if I start on the right-hand side and I get closer and closer to 3, what is happening to the y value? The y value is going up and up and up and up and up, all the way up to infinity. Okay, so based on what we've seen, how might we informally define what the value of a limit represents in terms of the graph? The limits are really going to be y values, and I know that that is something that Nancy Pye said in her video, and I think it is a good summary. It's the y value on the curve. And we'll have more formal definitions and things like that, but this is definitely an okay way to think about it. Excuse me.